Sometimes the difficult part of the problem is how to figure out the way if should be used for our problem. Here we have something that is called a triangular distribution. When we looked at our usual data, and here is the example of normal distribution, the graph went like this. On x-axis, let's say, we had people's heights. On y-axis, we had how many people there were with that height. So when we're getting nearer and nearer to the average height, we see that there is a really big amount of people with this average height, whereas there were fewer and fewer people that were either tall or short. This was the normal distribution law that was usually followed, but often in computers with computers we use what is called a triangular distribution because this is just so easy to calculate. In case of a triangular distribution, we have to set what is the smallest, let's say, height of people that we have in our case. We have to set the biggest height, and we have to set what is the most common height here, up here. And then the formula of the triangular distribution just simply draws a triangle between these 3 points. And once again, this is much easier to approximate with a computer. So this is the formula here. Let's begin by recalling something from the previous class, and at the very beginning we have to even give names. So let's select these four cells and give formulas, create from selection, and Excel gives it correctly at left columns because the names are at the left columns and they're given to the right columns. The second set of names we have to select is X and Y columns, and all together up till just a second, let me see, this is up till the 20th row, and the names are formulas, create from selection, top row. Now this is a new kind of a name, or this is a different kind of a name. We've seen it before, but it behaves differently. So here we have, if we select all the x's together, only then we have a x as a name. Now the way to build up this table was, we want to first see what the x-axis looks like, and then we want to calculate the y's based on x's to have that triangular distribution line nicely placed. So what we do here is, for x's, we write equals start. Always our table began with the starting point. This is 0 in the case of triangular distribution. And the second formula was equals previous plus step. Previous plus step. Now the start gave the beginning of the x-axis. The second formula had to be copied until the 20th row, and it always takes the previous value. The table is built from up to down direction. It always takes the previous value and adds a step to it. Thus the x-axis progresses from 0 to 10. And now we have to figure out a formula for the y to have the graph nicely drawn. As we see, there are actually 2 different formulas for y. If y is up to 5, the formula is, if x is up to 5, the formula for y is x times 10. So if x is 1, it's 10. If x is 2, it's 20. If x is 3, it's 30, and so on. Now, another case is true when the x is over 5. Then the formula would be 100 minus 10 times x, which is, if the x, for instance, would be 6, then x times 10 is 60. 100 minus 60 is 40. So we see that up to 5, the line will progress upwards and upwards until reaching 50 at 5. And then it'll start going down. So in the case of 6, it's 100 minus 60, which is 40, and it starts going down. In case of 7, it's 100 minus 70, which is 30. In case of 8, 100 minus 80, which is 20, and so forth. So we have a line at first going up, and then in the end going down. Now we have to figure out how to make an if that works this way. Now this is going to be a little bit more complex. It's going to be like this. We write equals if parentheses begin. Equals if parentheses begin. And now we have to figure out what is the condition which determines something in this if. It's actually, the condition is whether x is up to 5. So we write x smaller than or equals to 5. Actually, we could have written b10 smaller than or equals to 5. But remember, we can just nicely use this x as well, because in case of such long names that we have in blue color, it correctly takes the x value from this row. I mean, in this case it takes a 0 nicely from the entire block of x. Okay, let's write semicolon. And we now want to do the formula if x is up to 5, and the formula is rather simple. X times 10 is the formula. And now usually when we do this exercise in the class, we try to do it on our own, and now comes the hard part, what to do next. And some people think that they should write like x bigger than 5, something that perhaps another if is good here. But actually, if we think about it, we checked whether x was up to 5 and gave this formula. Now, when we're here, we have to put the formula in the other case. But in the other case, we already know that x is bigger than 5. So we can just write the formula 100 minus x times 10. 100 minus x times 10. And that's all. That's all. We have that formula working now. This is all good. So it checks whether x is up to 5, puts one formula. And if it's not, we know that x is bigger than 5, and it puts the other formula. And it works finely. Okay, let's copy this. And here it is. Up to 50, it progresses upwards, and then it comes down. Now, another case is how to draw this graph. Remember that we had three main types of graphs. Column chart was good, for instance, when we were dealing with, let's say, some areas of the rooms, in which case for each number we wanted to have a different column in the column chart. Line graph is good when we had a number of values, like for instance stock prices going up and down, and we wanted to have them on one graph. And once again, we're going to deal with graphs in more detail later on. But now we are going to choose the third most common type of graph. Namely, here we have those x and y value pairs. Here it is. Each point is given with an x and y coordinate. Yeah, each point is given with an x and y coordinate. And in this case, we select it all and give it what is called a scatter graph. Okay. And here it is. We once again have y as an explanatory text here twice, so I'm going to just try to select one of those y's and delete it, and here it is.